See if anybody else is here. Great. Yeah, thanks everyone so much for being here again. I know it's really hard to take on one more thing after work. Some of you are still at work. I can see from your video images. So really appreciate you joining from wherever you are, whatever you're doing. I'm honored that you are taking the time to be here this evening. For this webinar featuring the latest data puzzle lesson that I've put together, weather versus climate, extreme cold in a warming world. Believe it or not, this is a lesson that I've kind of been dreaming about for almost exactly a year. As an avid NFL football fan, I was really drawn to this game last year where the Kansas City Chiefs, who are in the Super Bowl on Sunday, were playing the Miami Dolphins. So this was about a year ago. It was -4 degrees. The quarterback, Patrick Mahomes' helmet was busted. Taylor Swift's there all bundled up. We've got 11, 20, I don't know, some double-digit number of people hospitalized from attending that and feeling the cold. And you always hear when you have these extreme cold weather events on media or people you might know, like, how could climate change be real if I'm so cold? And so this resource is an attempt to address that. So exploring the difference between weather and climate in the context of that football game last year. And so we're looking at extremes and then also going to be looking at changes in average winter temperature in a number of locations as our data set representing climate. So tonight we'll be doing that. It's not going to be super collaborative, but please feel free to chime in the chat. It's unbelievable that I've been doing this for so many years, and then the first thing that happens is I say, "Go to this link in the chat," and the sharing settings are not what they should be. So thanks for pinging me about that already. Um, yeah, and I should have introduced myself. My name is John Griffith. I'm a former middle school science teacher, climate scientist turned, I don't know, it's a kind of climate science communicator. I work for an organization called Ceres at the University of Colorado Boulder, and my job is to bring new and exciting research that scientists are doing into classrooms by developing resources like data puzzles. And so data puzzles is a product that I created alongside a number of other folks that are kind of concise lessons that combine authentic data with ambitious science teaching practices to support students in making sense of phenomena. So we'll go through the ambitious science teaching, I mean, the data puzzles instructional framework in the context of this lesson today. And just wanted to put this caveat in here that one, this is a draft lesson, and what that means is that it's been reviewed by the scientists we work with and our curriculum development team, but it's not been classroom tested. So just wanted to put that out there and also say, hey, if anybody is interested, in piloting this and testing this, we can offer you a $50 Amazon gift card for implementing it and then providing some feedback to me. So, um, hoping to learn with and from you in this space. In that same vein, thinking about, we working with educators, curriculum developers, who is creating these resources. I've introduced myself, but I am really a talking head for a much larger team. Series is the organization I work with. I work with 800 or more scientists at CU Boulder and NOAA to bring their research into classrooms. My colleagues, Dr. Anna Gold and Elise Thurber, are heavily involved in the development of these data puzzle resources, working with educators across the country. Believe it or not, my favorite part of this job is not sitting here literally in my bedroom writing these things by myself, but it's working with people and educators like yourselves. And so we do a lot of pilot work. Recently submitted an article into NSTA journals and have published a number of articles in that space with teachers. So really excited to get feedback from teachers and to share these resources amongst educators as well. Uh, Want to call out some other collaborators at University of Colorado Boulder, Dr. Melissa Bratton, who's a co-author of the Ambitious Science Teaching book, was heavily involved in the development of these resources. Jen Kay is the featured scientist in this data puzzle lesson. And then have been really leaning on Annette Brickley and Kristen Hunter Thompson of DataSpire for better understanding of how to approach data with teachers and students, what kind of data sense making strategies can we use in these resources? And you'll see some different moves, slow reveal, zoom in, notice, think, wonder, some different strategies that these folks have helped me better understand and refine and have strengthened these data puzzle lessons. So this is a hugely collaborative effort, and I'm excited that you're here and are interested in being a part of our team. I wanted to start briefly by just giving you all the kind of the brief history of this. So I was hired in 2019 to lead outreach effort related to this Arctic expedition, the Mosaic expedition, which was the largest and is the was the largest research expedition in the Arctic. Hundreds of scientists from around the globe participated, and they froze a ship in the Arctic sea ice. And that ship, along with the scientists and their instruments, drifted across the Arctic Ocean for an entire year, gathering all sorts of data about the Arctic climate system. And we developed a pretty good following from that outreach effort. And teachers after the expedition wanted to continue to engage with Arctic data in meaningful ways. And so we reached out to our friends at Data Nuggets and created a data nugget using some of these Arctic data sets, but wanted to do a little bit more and have a little freedom in terms of the instructional framework and the pedagogical strategies we were using. And so from that, we kind of tapped into a resource at CU Boulder, that being Melissa Bratton, and created this resource data puzzles, which brings together data sets, ambitious science teaching practices to support, again, students making sense of phenomena. Um, and so, for those of you that may not have a background in this, ambitious science teaching, the book that I've been kind of showing on the slides here, it's a pedagogical framework with principles, practices, and tools to support equitable science education. And so, again, they're practices, tools. It's not a curriculum. It's not, hey, here, go do this. It's strategies that you could use in your classroom. So, how to plan for engaging students with science ideas, how to elicit student ideas, how to work with these ideas, student resources to support ongoing changes in thinking, and then how to bring it all together to have them construct evidence-based explanations. So again, tools, principles, practices, all good stuff. But what we wanted to do with data puzzles is take out the planning, I guess, take out the planning maybe for you and put all of these pieces, put all these practices into a resource, into a structure that was kind of plug and play. So, with permission from the folks at Ambitious Science Teaching and Melissa's help, we created this data puzzles instructional framework. So we've kind of reworked some of the quadrants around. And all data puzzle lessons begin with this practice here, eliciting students' ideas. So, what happens in this eliciting students' ideas quadrant or practice, I should say, and we'll do this tonight, is students get an opening scenario, and that opening scenario has similarities to the phenomena that they'll investigate later on in the lesson. The goal with this opening scenario is to reveal resources that students are bringing to the classroom. These are ideas, experiences, language, through discussion that the teacher can then leverage thereafter to support students in making sense of a new phenomena, similar science ideas, but in a different context. After that, eliciting students' ideas practice, students receive an interactive reading we call the puzzle plot. It's got lots of images, videos, sometimes virtual field trips. And it introduces this climate phenomena, largely climate phenomena, and a featured scientist who's studying that phenomena. And from the big ideas in that reading and that interactive text, students develop kind of initial models for a question the featured scientist is investigating and make predictions about that question. Students then test their prediction in the supporting ongoing changes in thinking practice against an authentic data set that's been curated by that featured scientist. And so this is where we've been leading on Annette and Kristen at DataSpire to kind of help infuse really strong data sense making pedagogy into this part, and using different approaches to help students analyze data and identify patterns in some different ways. So then students revise their predictions based on evidence they gather from the data set and put the pieces of the puzzle together, so to speak, to construct an evidence-based explanation, which in many data puzzle lessons is an explanatory model, an annotated sketch, but in the case of the lesson tonight, it's actually a written explanation for like a newspaper article. So this is the data puzzle structure. All of the lessons follow this structure. And so the goal being that once you are familiar with this structure and confident with these different practices, you can likely go into other data puzzle lessons that you might be interested in and hopefully be able to get into my head a little bit, figure out your style with these lessons, and hopefully they can be more or less plug and play for you. So, given that context, we're going to explore the four parts of that data puzzle framework in the context of this lesson, weather versus climate. And what I like to do here, and I'll make note of it in that landing page, which I think some folks have just joined again. So, if you've just joined, here's the landing page with all the resources that we're going to be looking at tonight. Um, but I'd like to just pause real quick and take us to that landing page. So here's what that page looks like. And I'm going to go to the Data Puzzle website right at the top here and go check out the weather versus climate data puzzle lesson. So it's under the collection tab here, and it's right at the top. You can see we've got lots of data puzzle lessons, things looking at like snow conditions in the Rockies or inequities of climate change, mega drought, one that looks at changing patterns of forest succession, ecological tipping points, wind farms. So lots of different phenomena to explore. All pages look like this. You click on the link, and this is kind of the home page for this lesson. A little bit of context about the lesson and why it's important. And then the teaching materials down here from like heat maps that we are able to look at. We know that this all lesson resources is kind of the most popular link people go to because it's got everything there. So this has the slide deck, the student worksheet, the teacher guide. You'll see that the teacher guide has this draft watermark. And again, I mentioned that's because this hasn't been classroom tested. So perhaps some of you would be interested in embarking on that and providing some feedback for me. Um, and one thing that's missing that will be coming in the next week or two is an answer key. So those resources are here. I try to bury the answer key a little bit in the teacher guide. So just to make it a little bit harder for students, but these teacher guides all look the same. A little bit of background, brief description of the four parts of a data puzzle lesson corresponding to the four parts of the instructional framework. An instructional overview table with connections to the next generation science standards, the materials. This is where that answer key will go in the materials, some different vocabulary, and then the four parts are explained in a little bit more detail below. So going back to this homepage, that's in this all resource folder, but you can find specific materials here. They're all in Google Docs. or Google Sheets or Google Slides so that you can make copies of these resources and modify them to meet the needs of your students. My goal is to make them as plug and play as possible because it's a lot of work being a teacher, and creating new resources is something you all do all the time, but it's a heavy lift. So hopefully you won't need to make that many modifications should you choose to use this in your classroom. Any questions about the resources, what's available to you at this time? Cool. And just while I'm here looking at the landing page, the slide deck that I'm going through tonight is linked here. You should know that the slide deck that we're looking at together is not comprehensive. There are more slides in the lesson than what you're seeing tonight. Just wanted to give you like paint a picture for you, connect the dots so you see the thread. There's a link here at the end for professional development certificate. If you're here and want to receive a certificate for being here tonight, please complete that at the end of the session. And there's also an option to select whether or not you're interested in piloting this lesson. And if so, you could just check yes, and I'll be in touch about that. Resources for this particular lesson and then upcoming PL opportunities. I'll talk a little bit more about these at the end. You'll notice that tonight in this structure, it's kind of like I'm just talking at you, the worst kind of teaching. I understand that. But these PL opportunities coming later in the spring will be more collaborative and dynamic with myself and some of the colleagues that I mentioned earlier. So we'll talk about those at the end, but just wanted to point those out while I'm away from the slide deck. All right. What else was I going to note here? I think that's it. I don't see questions in the chat, so we're gonna keep moving. All right. So yeah, again, we're going to go through the different parts of the data puzzle instructional framework in the context of this lesson. Again, we're investigating weather and climate, looking at an anchoring event and extreme cold weather events, and then going to be investigating how winter temperatures, the climate is changing in the face of these cold weather events. One that we're in right now here, January in the US has been particularly cold. However, I just saw a New York Times article today that talked about how globally January, it's been the hottest January on record. So again, what you're feeling could be different than what's happening globally. This first part here, eliciting students' ideas. Again, this is not included in the student worksheet. And this is where we're eliciting students' ideas about an opening scenario that's going to have similarities to the investigation presented in the data puzzle lesson. So it's really key here that you don't skip this. We see this as like a part of a lesson that teachers typically cut out, and I think that they wish they hadn't in retrospect. It's really important to figure out what students already know and to use their language and their ideas as you're helping them make sense of something different. And so teachers have facilitated this in different ways as a warm-up prompt that they respond to in science notebooks. We've had teachers do think pair shares or work in small groups on whiteboards. Other people I know when they're using the tipping point lesson and exploring the ecological tipping points have even played Jenga to demonstrate that concept. So different strategies to elicit student ideas. In this case, the prompt is asking students to think back to the coldest winter day they've ever experienced, getting them to kind of reflect on what was the temperature, what were you doing, what were you feeling, where were you? I know this morning when I was cross country skiing with my dog and it was -5 degrees here in Vermont, my fingers were going numb. I have electric socks now that I can heat my feet up with that help me out there. And so maybe you're thinking about the coldest experience you've had thus far in your life, but wanting to give students space to think about that and share their stories. Being a former middle school classroom teacher, some of these stories are pretty silly. They invite curiosity amongst students and create an environment that is kind of more open and accessible to them. And after giving students an opportunity to kind of share that experience amongst one another, ask them if it's always that cold in the winter in that place that they were. Um, and so the point here is we're trying to highlight a weather event that was particularly cold, but also kind of sprinkle in the fact that it's not always that cold there, that there are cold weather events that we experience that are different from the way things maybe normally are, what they would expect. And use student experience as a way to highlight the difference between weather and climate. When we're thinking about weather, we're thinking about day-to-day temperatures that are driven by changes in the atmosphere. And so that would be the example of the really cold day that the student just described. Whereas what students might expect the weather to be would be climate. So I think looking back at that prompt, it's not always that cold in the winter. And perhaps you lean into that a little bit more, reminding students that the stories and experience they just shared are examples of weather and climate. And we're going to look at an example of weather and climate in the context of a football game that happened last year where the Chiefs played the Dolphins. It was the fourth coldest game ever. It was -4 at kickoff. But we know that this isn't normally the winter temperature there. In fact, the winter climate in Kansas City, based on a data set going back to 1975, is around 31 degrees Fahrenheit. So temperatures were what, 35? The difference was about 35 degrees Fahrenheit game time temperature and what we would normally expect. So what we're doing here again, taking student experience, highlighting their experience in the context of weather and climate, and then we're going to dive into this anecdote or this example here in the context of a football game to try to kind of hook students. And so, scientist Jen K here, many of you might be familiar with her from past data puzzles, but she is a scientist that's interested in winter weather, winter climate and studies these around the globe, these events around the globe, and understands that these temperatures are shocking and may lead many to wonder how climate change could be real. Could global temperatures be warming if I'm so cold? And so she's addressing this question by investigating some detailed data to look at winter weather and winter climate events across the United States. And so it's through that kind of connection, student experience, connection to the football game. Jen is studying events like what we saw at the football game that we introduce students to the puzzle plot text. And this is when you would distribute that text to students and learn a little bit more about Jen's work. So moving into part two of these, identifying important science ideas. This is when you're supporting students and identifying these ideas in the context of an interactive reading called a puzzle plot. And one of the goals of this is to help connect the ideas from the text back to ideas that were elicited in the opening scenario. So making connections between student experiences and what's presented in the text when possible. Students are asked to summarize some of these key ideas in an annotated sketch, which functions kind of as a de facto initial model. They identify an investigative question that a featured scientist is seeking to answer and make a prediction about that. Typically, what I've seen in classrooms is this is facilitated as a whole class read aloud so that there are opportunities to watch videos together or talk about the images or complete any like stop and jot little prompts within the text to pause and make sure students are making sense of some key ideas. Um, Students are always asked to circle the investigation and and underline similarities between the reading and the opening scenarios. These aren't really close reading strategies, just to kind of prompts that are generic across data puzzle lessons, because we want students and teachers to be discussing these similarities and we want students to make predictions about this investigative question. But I would encourage you, if you use close reading strategies with your students, to do that when you're engaging with this text as well. This is what the text looks like for the weather versus climate data puzzle lesson. For those of you that haven't checked it out, it's also in the landing page. On the left is page one, kind of an introduction to weather versus climate in the context of this football game, trying to draw interest into this event, showing the steam coming off these players, their breath being produced. This is the quarterback Patrick Mahomes and his helmet breaking. This is a video showing that happening because it's so cold and that helmet's so brittle. Taylor Swift saying high-fiving different some fans, and this is an individual who was hospitalized with frostbite having been to that game. So lots of different connections here that hopefully students can draw students in. Kansas City wasn't the only place impacted by this cold weather event. And you can see here is an image from January 15th. So this is a couple days after the football game, but it's all a part of that same cold weather system that dipped south from the Arctic. And so asking students to look at this map and hopefully make it relevant to them and where they are, asking them to look at the air temperature in their community on this date a year ago, around a year ago. Then we're diving into, okay, here's this cold weather event, but we know temperatures aren't normally like that in Kansas City, and normal temperatures are what we might expect based on decades of observation. So normal kind of being the climate, and normal temperatures or the climate that we might expect in Kansas City in January is somewhere around 31 degrees. So asking students to calculate that temperature difference. Hopefully you can see how this could be made interactive with students. And it's through all of this lens that students identify this investigative question. And in this case, we're focused only on Kansas City for the time being because that's where the football game was played. So despite this cold weather event, because of this cold weather event, we want to explore how average winter temperatures, kind of the winter climate of Kansas City, has changed over time. Is that cold weather event indicative of climate that's also becoming colder? Perhaps some students may think that, and so that's a little bit what we're trying to investigate here. Um, so students are going to make a prediction about this question as well, and then they'll test that prediction by looking at some data. Looking at the student worksheet here, a little blurry, so perhaps better to pull it off on your screen if it's available. But I really wanted to pull out weather and climate. And so the goal here with this human diagram is that students would draw how they would dress if they went to that cold weather game on January 13th, 2024, when it's -4 degrees, and then how they might dress in January 2026 if they went to a football game. How might they expect to dress based on the climate, the winter climate there? And so I wanted students to draw something as if somebody was dressed for a game that where temperatures were -4 degrees, and then draw a different outfit for a game that might be played when under normal conditions, normal being like the climate there of 31 degrees Fahrenheit. So they would get that information from the text. Um, Write a few sentences about the difference between weather and climate because that's really the crux of this lesson. And then document that investigative question and make a prediction. Do they think winter temperatures have increased over time, decreased over time, stayed the same, and then defend their prediction. in some way, shape, or form. So this is that identifying important science ideas, going through the text, and then documenting some of these ideas, making predictions here. Uh, the next part here, part three, supporting ongoing changes in thinking, is when students are testing their predictions. And facilitation strategies are things that are also embedded in the slide deck. So we found that it's really important to review some of the research and key ideas from the puzzle plot again before diving into the data. We're really emphasizing that teachers and students talk about the graphs before they go individually or in pairs to analyze and answer scaffolded questions on their own. And so we really are trying to help students describe visual patterns amongst one another before they record them for themselves. Some strategies are a zoom in strategy. You can zoom in on different parts of the graph, or slow reveal. Perhaps some of you have heard of that, showing different parts of the graph in some kind of sequential order to highlight a pattern or highlight some feature of the graph. As I mentioned at the start, we'll be highlighting some of these different strategies in professional learning opportunities later this spring and really digging into them in more detail. Um, in this case, again, the key idea here is this difference between weather and climate. The football game being an example of this cold weather event, and how that's different from the climate that we might expect based on this 1975 to 2024 average winter temperature. So, difference between weather and climate. We know that temperatures are going to go above and below this 31 degrees. The weather's always changing, but is the climate changing? And to really get at climate change in terms of winter climate, we need to look at average winter temperatures climate over an extended period of time. And so that's what we're going to do here. If you recall, we had students make predictions about whether average winter temperatures would be increasing, decreasing, or staying the same. And so that's what we'll do here with Jen's data set. She's collected this 50-year data set of winter surface air temperatures from Kansas City International Airport, which is pretty close to the Chiefs Stadium. And so we introduced this data set to students just by looking at this blank graph. Perhaps we talk about the axes. This is average winter temperature in degrees Fahrenheit from 20 to 40 here, over this 1975 to 2025. I can't believe it's 2025, the year on the x-axis. And so can ask students to think about, um, what might they expect to see if average winter temperatures were increasing over time or decreasing over time or staying the same. So kind of prepping them before they see the data to talk through what they might expect to see. Does this We'll get there. So in this case, I've decided to use the slow reveal strategy. And so the next slide here, these are some prompts that you might show with students and things that we've kind of tested in other resources. So we're showing one part of the graph here. What new information did we learn? And so in this case, maybe we're giving students an opportunity to think for themselves, or talk to a partner, and they're looking at this graph. It's got it's a red line, wiggly, starts high, goes really low here. And so what are we trying to get out of this from students? We want them to see that there is some variability, that temperatures go up and down each winter. And perhaps they're wondering, you know, what happened in 1979, or wow, why was it so warm here? I can already see in the chat questions emerging. And if others have wonderings, please jot them in there in the chat as well. But if the variability, the ups and downs reflect different differences in La Nina or El Nino patterns. I don't know the answer to that question in the chat, which is a great chat. This is average for the winter season. Yeah, thanks for pointing that out. I should have made that clear in this graph. This is average winter temperature, which is December, January, February. And so overall, what we might expect or what I'm hoping we see here is that there's some variability here, but we see this kind of increasing trend temperature that looks like with the exception of this 1976 year, like we're low and we're seeing this increasing trend over time. The year 2000 from 1975 to 2000. So variability, but we see winter temperatures increasing. What do you wonder? Well, maybe people are wondering whether they're connected to larger phenomena like El Nino or La Nina, or maybe they're wondering what's going to come after this. Are we going to see this continue to increase? Will we see it decrease? What happens? And the next part of the graph is revealed. What information did we just learn? What do you wonder? In this case, we just learned we're looking at average winter temperature from 2000 to 2024, the year of the football game. You can see that the average winter temperature in 2024, despite that cold weather event, was pretty high, over 35, around 36 degrees Fahrenheit. I don't necessarily see any kind of increasing or decreasing trend in the last 2 decades in terms of average winter temperature. I could see that average winter temperatures don't ever go below this 1979 event. Um, and so basically, yeah, we're just trying to have this conversation with students. I selected this data set in particular because there is variability. It gives students an opportunity to kind of see the messiness. We see this clear increasing trend despite that variability from 75 to 2000. And after that, there's that variability, but that increasing trend kind of pauses. Despite that fact, if you were to run a trend line through this, as I do ask students to do in the student worksheet, which maybe you would have to support them in doing that, there is a statistically significant increasing trend through this. Um, and so, despite the variability, or in spite of the variability, which is what we see on a year-to-year basis in terms of winter temperature, there is an overall increasing trend in average winter temperature for Kansas City. So you wouldn't necessarily say all of those things when you're engaging your students with that practice, that slow reveal. You're challenging them to say what it is that they're seeing, ask the questions that they have, their wonderings. Perhaps you're recording their wonderings or having them put those on sticky notes. But you're using that with students. You're using that strategy with students again to talk about the graphs, to get students kind of familiar with the graphs, and to hear it is what they're thinking and meet them where they're at. Some of the questions in the student worksheet are a little bit blurry, but again, kind of in the same vein, getting students to appreciate the variability here, having students explore the range of data shown in the graph, taking the highest and lowest temperature and find the range of data, asking them to make a trend line and describe that trend, and then revisit their prediction for the question, how has their prediction maybe changed or not changed based on analyzing this data set. I'm looking at the chat right now. North Carolina students in seventh and eighth grade discuss these weather phenomena and their effects. So no, it will be asked by students. Great. Yeah, and I think perhaps I can link that New York Times article. I know that we're in a La Nina this year, and again, like I'd mentioned, despite the U.S. having a relatively cold January, as noted by a number of events, the inauguration being inside, the Southeast getting lots of snow recently, perhaps in North Carolina as well. Those La Nina conditions, I think, have helped facilitate temperatures globally that are higher than we've seen. And so I'll find that article and share that. And perhaps that's something you could share with your seventh and eighth grade students as well. Um, Wow, we're almost at time. Sorry, I'm so long-winded. After going through that data set, discussing it, getting students into those scaffolded questions, we're supporting them in constructing an evidence-based explanation. In this case of this data puzzle, I don't have them construct an annotated sketch, a model, because there isn't really a mechanism included in here. There's nothing really about climate change and what's driving it. Really, it's just showing that extreme weather events, extreme cold weather events, are not indicative of larger climate trends in terms of what we're looking at for the winter here. So, asking students rather than to write an article, asking them to identify three key ideas that they would put in their article, create a headline, and that's kind of the summative task for this lesson. This really has a Kansas City focus at this point, and if you're not in Kansas City, like students like in North Carolina, like why do I care what's going on in Kansas City? So to kind of bring this to everyone, we look at a different data visualization and this digging deeper prompt. All digging deep, all data puzzles have this question at the end, or a new data set or some social justice issue for students to explore. In this case, we're looking at a data set from the EPA climate indicators that has compiled winter temperatures, average winter temperatures, December, January, February over the last 125 plus years. And we can see across the United States, winter temperatures have increased. Asking students to perhaps identify on the map where it is that they live. How have temperatures changed there? Looking at this legend here, what do the different colors represent? Why are these northern states warming more rapidly than other parts of the country? So lots of different things you could do with this to bring it home for students and where they live and meet them where they're at. The reason that I chose not to use this particular data set in the data puzzle lesson is because I was trying to show that there is variability year to year in average winter temperature and demonstrate that just because you have a cold winter doesn't mean that winter temperatures year to year aren't increasing. So I did feel like the variability and the opportunity to create a trend line was an important part of this lesson, but also wanted to have this opportunity at the end for students to explore changing winter temperatures in their state and their hometown or look at trends across the country. So that is the lesson. Notably missing from this lesson are any mention of like a mechanism, the polar vortex, climate change in the polar vortex. And that was intentional. I had it in there and then removed it because I felt like it distracted from the weather versus climate message that I was really trying to emphasize here. So you could feel free to bring that into your classroom as like an extension or a next thing. Um, the science is still out there to a certain extent about how climate change, rising global temperatures is impacting the stratospheric polar vortex. There is evidence to suggest that the rapidly warming Arctic is reducing the temperature gradient between the equator and the Arctic, and that is kind of weakening or destabilizing the polar vortex and causing the vortex, that cold air mass, to shift south more frequently, which is what was experienced in 2024 in this example, and what we've experienced at times this January. But given the complexity around that, I decided to not make it a focal point of this particular lesson. Uh, it is certainly something that you could bring up and investigate with students, but it's not in here. So just wanted to call attention to that for those of you that are in here wondering why that's not here. And hopefully that makes sense. And if you're interested in connecting students with the polar vortex and thinking about that, I hope that this structure, this framework makes that leap a little bit easier. That's it. For me, I know I'm a couple minutes over. If you have to go, that's fine. That makes sense to me. I'm gonna just talk for another moment. Hopefully folks can hang on. Apologize for going a little bit long here. In the chat, I'm gonna add um this Google form that I reference here for a 1 hour PD certificate. If you're interested in that, fill out this Google form and I'll send you a certificate tomorrow. Also in that form is a question asking if you're interested in piloting this lesson. Basically, that would mean you'd use it with students and then meet with me to talk about how it went and what you'd like to see different in the lesson or how you modified it. And that would inform how I modify this resource moving forward. And I also want to call attention to some other PD opportunities this spring that'll be far more collaborative than this just kind of lecture approach here. So um, a we were just awarded a grant from the National Science Foundation to do some research with middle school science teachers to learn how data sense making practices and structured data puzzle lessons support their students explore and explain climate phenomena. So we're going to be facilitating a larger professional learning event. But before we do that, we're trying to test some of the things that we plan to do in some different pilot events this spring. And so some of the themes that we're interested in exploring with middle school science teachers, data sense making practices in these data puzzle lessons, and how we can support teachers integrate these lessons cohesively in their curriculum. And so in the landing page, which I'll go back to here, you can see that there are a couple of different offerings in the context of different data puzzle lessons. So the notice, think, wonder strategy in the context of this not all warming is equal data puzzle lesson. Again, for middle school science teachers, it's a two-part hour-long virtual event. And again, folks would receive $75 for attending and participating. Zoom in strategies in the context of mega drought, and then how to integrate data puzzle lessons in your curriculum. So again, these are going to be far more collaborative, and we'd be really excited to have folks join this professional learning community and hear from folks about what works and what doesn't work for them in these PL events. So that's all in the landing page. Also want to make a nod. Those data sense making practices are heavily informed by Kristen and Annette, who I've mentioned a couple times tonight, and their work with DataSpire. And so this was actually a webinar that I was at, not this particular webinar, but a webinar they were leading last night, something I was at, a different share out event. This is one that's coming up in March. Much of what I do with data puzzles is informed by what these folks do. So if this is something you're really excited about and want to get more into this community, maybe check this event out as well. I'm seeing in the chat um if you noted that the the Google form wasn't published. Thanks for flagging that. I'm hoping that now it is published. I see that somebody was able to respond, so I think that is the case. So again, if you are looking for a PD certificate or want to pilot test this with me, please complete that certificate. And for the rest of you, that's it. That's the song and dance. I hope you got something out of this tonight. And I hope that you are excited to use the lesson or parts of the lesson or some concept with your students moving forward. Hopefully you got something. And I really, really appreciate you being here. I'll stay on to chat or answer some questions. I'm gonna stop.